Welcome back. So we continue the look through the various SMC questions, and there's a few different ones coming up, and we are indeed going to end with the most difficult one on the paper, but we'll get there eventually. So let's start with this one here. As you can see, an index rule question. I don't think this is the hardest question, but remember it's non-calculator, work it through slowly. Back in a second, let's see how you do. All right, so this could be, frankly, a GCSE question because they've started making the GCSEs a lot harder in these terms. So nice question, may well appear in one of my lessons quite soon with my sort of lower years. How did you do? Now, for me, pretty obviously, this first thing is about getting everything in powers of 2, and this second thing is everything in powers of 3. Obviously, other numbers will work, but powers of 2 seem easiest. It will probably give you the best solution. So let's start with the one on the left. So I'm going to rearrange everything in powers of 2. So that's going to give me what's on the screen now. I won't read it out. And let's do everything so it's 2 to the power of something as opposed to fractions or similar. I've also collected the terms. So when I multiply, I add, as I'm sure we all know. And so this gives me this expression here. The key to all these questions are you want to get the base the same. And if the base is the same, that means the powers must equal each other. In other words, I can say 2y is equal to 3 minus 1, which is minus 4, minus a half x. Do a little bit of rearranging to make it slightly neater, and I've got x plus 4y equals minus 8. I'll call that equation 1. Equation 2, again, I'm feeling 3s here. By the way, really common thing I see in lessons is people get this one wrong. I don't know why. I think maybe they don't like the 1 here, or you don't see the 1 or something. But either way, I'm going to rearrange this as powers of 3. So that's going to give me 3 to the 2x times 3 to the y equals 3 to the 1. Again, common issue, times 3 to the half. Bit of collecting. And ultimately, that gives me this expression here. So this one's not terrible. 2 expressions, 2 unknowns. Let's make the first one twice as large. Then I can just take away the second from the first, and that's going to give me, looks a little bit messy, but 7y equals minus 35 over 2. But of course 7 goes into 35, so that makes it all nice and neat, so y is minus 5 over 2. Now I will say, for a question like this, I probably would have expected integers just because it's a non-calculator paper, but 5 over 2 is a pretty common, it's one of the common non-integers you tend to hear. So I'm not massively upset with this one here, so let's continue. Put it back into equation 1, so x equals minus 8 plus 4 times minus 5 over 2, and that's going to give me x is equal to 2. Feeling a bit better, that's an integer, nice, easy integer, feels good. All right, next part. So I haven't finished because I need to work out the value of 5x plus y, so add my x and y together. Well, that's going to give me 2 minus 5 over 2, which is 4 over 2 minus 5 over 2, or minus a half, which is otherwise known as 1 over root 5. Is it up there? Yes, it is. It's answer E. So answer E is my answer today. Well, I don't know if you got that. I didn't think that was a terrible question. In fact, a nice little question just to sort of give you a bit of a boost before the slightly harder questions come. As ever, like, subscribe, any comments below, any feedback, gratefully received, and I will talk to you all soon. Thanks all.